So if we look at the question or the statement, it says that the probability of someone um, being told that they have hypertension is 15%. And that means that the probability of someone not being told that they have hypertension is 0.85. Let me just write 8 here. I'm actually looking through my phone, which is terrible. And they say the sample size of the adult was n equates to 12. So, okay, now we're going to look for the value of x, but that depends on the question, so it varies. So now, okay, the question says that, suppose that a random sample of 12 adults is taken. What is the probability that more than 10 have not been told that they have hypertension? So note that is that have not been told that they have hypertension. So usually our formula, it's like this for binomial distribution of px equates to, let me just write in meter here, px equates to, and px is also equal to that big X equates to small x, which is n over x, and then it's p over x, and then it is q of n minus x. So now here we're focusing on not, which is this part. So we can simply just switch them and we just say p equates to 0.85 and then q is equals to 0.15. Okay, now we can rewrite the same formula here, but now we say at least 10. So if p x greater than 10, not equal to 10, equates to, we can just rewrite this formula, which is just distribute this one. So we know that this is actually the same as greater than 10, so that is p x equates to 11, plus p x equals to 12, which is the final one. Or if it's too long going this side, so this is because now we're only dealing with these two, but it was too long, we're just going to do the reciprocal of it. So we were going to just say it is 1 minus this one going down. So it is 9 plus 8 plus 7 plus 6 plus 4 plus, or 5 plus 4 plus 3 plus 2. So, but then we're not dealing with that because this one is the shorter side. So we just work with this one. So, okay, now this one, let's distribute it. What does this part mean? This part means that x equates to 11, and this part means x equates to 12, but q and p don't change. So we have the value of 12, and then this is 11. And then here we have p, which is 0.85 to the power of 11, and then we have our q here, which is 0.15, and then it is to the power of 1 because 12 minus 11 is 1, and then it is plus p to the p, which is 12 here, 11, and then we have our p, which is 0.85 to the power of, or this is 12, and this is 12 also, and then the other one becomes 0 to the power of 0, which is 1. So we could just not write it. So this one, note that this is equate to 1. So this one is a number, this one is a number. And I already pressed this one on a calculator, which is the same thing, and it gives us the answer there. If you go here, it's the same thing that I already pressed here. So you just say equal to 0. So p of x greater than 10, or p, probability of someone at least, probability of at least people being told that they have probability of more than 10 people not being told that they have hypertension equate to 0.443. Let's round it off. This is 34, so it is 35. Okay,